It's very exciting to have a joint seminar this morning, especially on reproducibility, one of my favorite topics in the world, I have to say. My name is Yolanda Gil. I'm from the Information Sciences Institute, from the AI group. There's about 150 people doing AI research here. We're part of the School of Engineering. I say these things because there's a lot of visitors. And we're very interested in reproducibility in AI. And we have partnered with NEDA and their group to talk about reproducibility in AI and neuroscience together. So can you say a few words about your group?
Sure. Well, thanks, Yolanda. I think some of you in the back know me. But we are doing a lot of work in reproducibility in neuroscience because neuroscience in particular has had a pretty bad reputation fairly recently in terms of the results being reproducible. So we've been working over the past 10 years to try and address this. And I'm really excited about the session today because we can see how we can bridge the reproducibility aims across different disciplines and see what we can borrow from each other. So excited, and thanks for joining us.
Okay. So the format we're going to follow is that we will have two speakers. Each is going to speak for 30 minutes, and then we're going to have 30 minutes of discussion, and then at noon. Our first speaker today is Erik Gundersen. Erik is an AI researcher. He's done a lot of very good work on case-based reasoning and machine learning. He's from the Norwegian University of Science and Technology. He did a seminal study of AI papers and their degree of reproducibility that was very well received and really made all of us think very hard about reproducibility in AI. And he's talking about shoulders. So thank you.
Thank you very much, Yolanda. So I'm during daytime I work in a renewable energy company as a chief AI officer, where I lead the AI department. And during evenings I teach master students at the Norwegian University of Science and Technology in Trondheim, Norway, where we in AI and computer science. And during evenings and night times, I research reproducibility. And this is actually what I like to talk about, so I'm very happy to be here. The reason that I'm here today is because of Yolanda. Not because she invited me today here, but because she gave a keynote at the international conference on case-based reasoning in 2012, where she talked about the reproducibility crisis. And I have to be honest, I was so surprised that there was a reproducibility crisis going on. I immediately thought that this is a huge problem. We are scientists. We're not able to reproduce the results of other scientists. How can this be? And I started digging into it. And some of the things that you will talk about today is the thoughts I've been pondering on since 2012. So, okay, how many of you have tried to reproduce other researchers' results? How many of you have had problems? Oh, basically the same amount to actually try to reproduce all these results. And that is, you're not alone. The year after I attended this keynote with Yolanda, I actually tried to reproduce some papers. I went to the same conference, ICLR, and I asked people who were presenting their research at the conference and said, "Hi, I would like to reproduce your research. Please come over to me and I'll try to reproduce it." And what happened was that there were 3 PhD students came over to me and said, "Yeah, come and reproduce my research. I'll give you the stuff you need." So the first one I tried to reproduce, got the code, tried to run it on my own computer. It was running on some web services, PHP and Apache and so on. So I had to install these libraries and get the stuff running on my computer. And then I got it running, very happy. And then I had no data. So I went over to this student and said, "Okay, could I get the data to reproduce the research?" "No, I'm sorry. I can't give it to you. We collaborated with a company and they don't share the data, so I cannot." So okay, first attempt wasn't possible to reproduce the research. Second attempt, was a PhD student gave me access to his code, and I tried to run it. And then we had a break, and I was wandering around in the conference. And then his supervisor, professor, came on to me and said, I heard that my PhD student had given you the code for the project and so on, but he's not allowed to do that. So you have to delete it. And that was the second attempt. I had to delete the code. And the third, this is ICBR is a computer science conference. Third student, I went to him. Oh, I haven't gotten your code yet, and stuff. And he said, "Yeah, no, I'm sorry. Thing is that I did this experiment, and I published the paper. It was accepted, and then I did new research. So I wrote over this code. So he didn't have a person control system for his code. So that was my 3 attempts, and I thought, okay, something has to be done. And it seems that I'm not alone here. This is from a very much cited study on Nature, where they asked some the users on their webpage to answer some questions, and they found out that 52% of the respondents, or around 1,600 as you see, said that yes, there's a significant crisis in reproducibility crisis, and 38% said yes, there's a slight crisis. And to me, sort of crisis or no crisis, there's no sort of degrees of crisis here. To me, that's sort of saying yes, we have a crisis. Question?
I claim that this result is itself not reproducible. I mean, which disciplines were queried? I'm sure it varies a lot by discipline.
Oh, yeah.
Which disciplines are more susceptible to reproducibility?
Yeah.
So then which people are more likely to respond to this?
I totally agree. So there are many problems with this survey. Totally agree. And that they actually asked many more questions than only this one. So if you look it up, you'll see that, and they talk about the different biases in this study. But it gives us some indication that people think there's a crisis going on.
Well,
are you going to touch upon maybe the distinction between reproducing and replicating? And I think that the examples that you brought up, the 3 cases that you were trying to reproduce were, they are kind of borderline in my mind, because there are fairly legitimate reasons why you wouldn't necessarily be able to, let's say, access some data. There might be ethical restrictions on the data. So are you going to touch upon all these things?
I totally agree. So we'll talk about this later. So if I haven't answered all your questions when I'm finished, you can throw stones at me then. Okay, so this is a very interesting reproducibility challenge that was done on the ICLR conference, National Conference on Learning Representations. And it was organized by Joel Pinot at McGill's University. And the thing with ICLR is that they have an open review process. So you submit a paper, it's submitted openly, and then the reviewers are anonymous and they review your paper. But the thing is that everyone can read your paper during the review process and ask questions. So what they did, there were several professors who had their as part of the courses that you had an exercise in reproducing papers. So very interesting. They did the same thing as this Nature survey. They asked questions. Do you think there's a crisis? Yes, a slight crisis, 50%, significant crisis, 22%. So it's around 70% that thinks there's a crisis, but sort of different amount here. And then they did the reproducibility challenge. So this was before. It was around 98 respondents that were trying to reproduce papers. So before they reproduced papers, this was results. And then after they had tried to reproduce, has your opinion changed? And as you see here, half of them didn't change their opinion. Some were less convinced, but 30% were more convinced after trying to reproduce other papers. And they were able to discuss with the papers the results. in the comment section of this open review. And of course, the authors were interested in answering these questions because it was part of a review process. So to me, and this is not the situation most of us are in when we try to reproduce someone else's work. We might not even be able to get authors to answer our questions. So I think this is quite serious numbers. If you don't think there's a reproducibility crisis, well, these numbers should maybe kind of convince you. And I will just talk a bit about some papers that are out there in the AI world first to also motivate the problems that we see. So this is also a paper. I'm sorry, I haven't given you a reference for it, but the title is Deep Reinforcement Learning That Matters. That was published at AAAI in 2018. Joel Pinot was one of the authors. I think the first author was Gundersen. He's now a PhD student at Stanford. And what they tried to do was to reproduce different deep reinforcement learning algorithms. And they found quite a lot of problems. For instance, if you do a deep reinforcement learning algorithm and you've made your own and you want to test it, you want to benchmark it. And the thing is that I want to benchmark this towards a baseline, and this baseline is a known, very known algorithm that's out there. So you do this, you run your algorithm, you run this baseline algorithm, and you get a result. And typically the result is that yours is better. So that's why you publish this. But the thing is that they tried this baseline, it has different implementations. Okay? So based on the choice of the implementation that you did, you will get different results. And maybe your results will not be that good, or it might not be better than the baseline if you choose a different implementation. So that is concerning. And they found that you had problems with these deep reinforcement learning models. They have their neural networks, and the weights in these neural networks have random initial values for all their weights. And what they found was that we have this one algorithm and this other. They are both deep nets, and we run them on some task. And for every experiment we do with these implementations, as long as we keep the weights the same, this algorithm always dominates this. Okay? And then they changed the random weights, and they got the total opposite result. The other algorithm will always dominate the first one. So changing the weights of the neural networks would totally change the result. Okay. And they were also very specific to how they run these deep reinforcement learning algorithms, and how they specifically measure performance. They saw that this typically measures that they take out the 5 top results from 10 runs maybe and compare them, and you had very skewed results because of this. So, and of course, with deep reinforcement learning, they are typically done in this type of gyms, lots of stochasticity in the environment, and that also affects the results that you get. So many problems, very, very hard to reproduce. There's another one by, I actually don't remember the authors, but they are GANs created equal, first part of the paper's name, and they did something interesting. They looked at, so the first generative adversarial neural network was proposed in 2014 by Goodfellow, and after that, several different implementation of GANs has been proposed. And in this paper, they take all of these different implementations of GANs, and they do a sort of fair and objective measurements on all of these in the same environments. And all these new GANs, they are proposed because they perform better than this first one. But this shows that that's not actually true. When you compare all of these methods, they are basically the same. the first method is not worse than, and then this new implementation is basically on the same level. But it's of course how they measure the performance in their experiments that's the problem here. So they suggest some systematic and objective evaluation procedures instead. And this third paper I'm going to talk to you about is a paper that I find very interesting. It's by Hong et al. And it's from 2013, and it's about weather models. It's not very much cited, but I found it very interesting. So they have a weather model, very large weather model, and they want to run this. And they have some initial conditions that they feed into this weather model, and then they run it for some time and to see the results. And they vary different hardware, different operating system, different parallel communication libraries, and they have different optimization levels for different compilers, and then they look at what are the results we get. And they are totally different for many of these implementations. They are actually so different that you could do different initial values for the simulations. So you don't have to run model with many different initial values. You can just run them on different hardware with different compiler settings and on different operating systems. Okay, so this was to motivate you that we have some problems. I'm going to talk a bit about defining reproducibility. So if you look at the literature for reproducibility, you'll find that there are many different definitions. It's almost as many different definitions as there are papers about reproducibility. And this one is one by Roger Peng in Science 2011, where he talks about you have different degrees of reproducibility. So reproducibility is not one thing. Either you reproduce the result or you don't. There are degrees here. And that's one of the things that are very interesting about this paper. And this is something that most people that are talking about reproducibility agree on. So, and he talks about that you have publication only, and it's not reproducible. And then you have code and data, linked and executable code and data, and then you have full replication. Okay, let's start thinking about this. If you have the publication only, it's not reproducible. Okay, what about Newton's method? Okay, that's a method for computing stuff. And he didn't have a computer with linked, executable, and code and data. So, of course, it's utterly nonsense. There are others, Victoria Stodden, very good researcher, says a lot about reproducibility. She had a paper in 2011 where she talks about replication and reproduction as sort of two different degrees of reproducibility. It has some problems to it. The one is to rerun the experiment with code and data provided by the author. The reproduction implies both replication and the regeneration of findings with at least some independence from the code and or data. So to me, there's something that doesn't work. So it implies both replication, that you run with everything that the author had, but also with difference. What does this mean? So it's not really, I don't really comprehend this definition. And this is a very known definition by Goodman et al. And Ioannidis here, one of the most prominent reproducibility researchers, maybe, which has three different degrees here. And I will not go into this in depth, but when you read them thoroughly and start thinking about them thoroughly, they're not really, they don't really fit together. I cannot really understand them. They talk about some part of it is what you share, so the code and data and sort of the methods that you share, and parts of them talk about results, but not really exactly what this means. So there are some problems with these reproducibility definitions. And I, of course, being a researcher, we don't have enough definitions. I tried to do something with this, and I my thinking is that reproducibility is about others reproducing research. So you cannot reproduce your own research. You can repeat your research, repeat your experiment, but you cannot really reproduce it because there's something about the methods that had to be implemented that are inside my head. They need to be transferred to someone else's head. That's a core part of it. So it has to be an independent research team, and we have to produce the same results. That's the main thing, and it has to be done based on the documentation. Okay?
You notably exclude data from this. So it doesn't have to be on the same data set, similar data sets. I mean,
documentation. That's the key word here.
But documentation, not data. For example, AI algorithms, like the image recognitions, for example, MNIST doesn't benchmark everybody.
I know. Let's go further. I'll talk about that. So this is generally the scientific method. And how we typically do it in AI, I think. So we have some beliefs about an AI method typically. You have to design a study. You have some hypothesis and prediction based on what the experiments you're going to run and results. And results, when you run the experiment, you compare the results you have with your hypothesis and prediction, and then you sort of can interpret this and you can adjust your beliefs. That's basically the cycle here. Yes?
Can I ask a question about the definition that you provided earlier? So I think the most interesting word in your definition is actually same, where you say same results. What does it mean same for you?
I totally agree. I totally agree. And this is the key. You just find the key point, key problem with this definition. Totally agree. And I made this definition knowing that this is key point, because this is not the key problem with this definition. It's the key problem with reproducibility. We don't really know what same results means. And when can we say that results are the same? And I'm going to talk a bit about that. So, and of course, when you look at the same figure, here there's lots of stuff that goes into every of these steps. You have to design the task and the data and performance metrics that you're going to use for interpreting your results here. You have to have experiment code, I call it, but this is typically workflows. Talk about how is your experiment conducted. And then you have some method code, your AI method, your neural network, so on. And you might have some pre-processing code for your data. You have the data, you have some ancillary software such as the operating system or Python or PyTorch or whatever, and then you run it on some hardware. And then, of course, the results has to be you have some performance metrics code, implementations of your performance metrics, and then you visualize it and so on. And then you can interpret your results. Documentation. I argue that there are three sort of dimensions of documentation. I call them factors. So you have the method, that's the AI method that you want to test, your neural network, decision tree, whatever, including a description of your experiment method that you're going to. It's a human-to-human textual description of what you're going to achieve. Then you have the data. It's part of the documentation, I argue. And then you have the experiment, which is basically code and hardware that you're running your experiment on. And then, which I said that basically everyone agrees that there's a degree of reproducibility here. And this degree of reproducibility, I argue that if we define reproducibility the way I've done, say that it's done by someone else, and that you need documentation and you have to compare results, I argue that you have different degrees based on which type of documentation that you share with others. So if you only share the paper, you have one level, so one degree here, where I only share my paper. It's still interesting. It's still valid. It's important. Many of the most important results, we only have papers. For instance, the DeepMind papers. Only papers there. So AlphaGo. Still, you can reproduce it. Facebook used like 3 years, lots of resources on trying to do that, and finally they were able to do that only based on on the paper that is released. But then, of course, if you have shared the paper with the data, it's much more easy for me to reproduce the results because I have the data and I have your method. I can implement them myself and can run them. Then the uncertainty on whether I'm able to reproduce the same results as you are is only based on my implementation and the hardware I run it on. But of course, if I only have the paper, I need to bring some data myself, and there's uncertainty whether the sample I'm having in my data actually reflect the samples that you have, and both of them reflect the actual world. Okay, and then of course, if I have code, data, and method, the only uncertainty here is in hardware, compiler settings, and operating system, these kind of things. It might still be that I'm not able to reproduce results, but that's basically how close we'll get unless you don't have the exact same hardware and your lab. And then what we tried to do here in the study that Yolanda talked about is that we had these different factors. We divide them into different variables. We said that these factors can be described by variables, so that you had the method. You could say that I had to describe my problem in the paper, objective, research method, and so on. And for data, did I divide into training, validation, test data? Did I share the results? And for experiments, did I share the source code and for the experiment setup, and so on? And if I do this, if given these variables here, so I have a set of variables. What we did is, in this study, we went through different papers, and we saw, have you shared this? Have you described this? Check, check, check. Yes, no, yes, no, yes, no. And the good thing about this is that now we can quantify how well did you document your research. Okay, so if you only shared the paper, okay, we had some variables describing how well you wrote your paper and how much of it you shared. So we can actually document that in the paper so track this and record these variables. And we can score your paper or any paper. And same for the different other degrees. We could score how well does it. We'll take it later because I have so little time. 5 minutes only. And if we do this, and these metrics that we set up here, it's basically a boring weighted mean of all the variables, okay? But it was just to sort of give to show an example, to show that this is how we can do it. And if we're able to sort of define these different variables that are interesting, and that will be we will need in order to reproduce paper, then we can actually grade papers based on this. And the good thing is that we get a normalized metric. And so why does this make sense, having these metrics? We can specify how well research is documented. So I can read your paper, I can and I can give you a score. And we did this for 400 papers from ICLR and IIII, 2 different years. And we score them. And it's interesting to see that more than half of them had pseudocode. Very nice. It's easy for me to understand what you're doing if you have a pseudocode. Very few of them shared research questions, research method explicitly. Even the objective of your research wasn't really explained in many of the papers. Even the problems. We solved this problem. No, very few said that. And in some papers, I'm not even able to understand why you're publishing this, because it might be a very narrow thing, but at a general AI conference, many different people might read your papers. So if I don't understand why, that's a problem. Very few share the results, the explicit results. So some of them share the training data, few share the test and validation sets, but none shared actual research results, which is basically, so I have this, these are my images of cats and dogs, and when I run my algorithm them, in my final run, this image was classified as a dog, even though it was a cat, and so on. Just a listing of the results. Very few share this. And for me, in order to be sure that I actually do the same thing as you, I need to understand this. And then score, interesting experiment setup, very many recorded this. We never tried to implement this, so we don't know how detailed it was and whether it was detailed enough. I mentioned it was. Good thing if we do this, as we did, you can compare different conferences over time. So you can say, have we improved over time? The answer is no. We can compare papers individually. We did this for another study. We can compare different conferences to each other. Is this conference better than the other conference in producing quality papers? We can compare research groups. This is from a paper that is published in AI Magazine later this year, where I look at academia versus industry, and we find out that academia, although not really good, is better than industry. And some would say, yeah, but we knew that. But to me, this is a surprising result. So we have these double-blind reviews, okay? And even though, so this, we have a bar here for getting papers accepted at top AI conferences. But industry is still able to not share as much as academia, okay? That is, I wasn't prepared for that because of these bars. And then this is what I'm going to present at the eScience conference in San Diego on Thursday, is that we went through a lot of different machine learning frameworks, and we were looking at them and said, okay, do these machine learning frameworks, do they provide the possibility for me to reproduce my work or to share the work with others? And do they have the features that I need for reproducing according to the set of variables that I presented to you? And the answer is to some degree.
Is blue good?
Yeah.
Is blue good or is...
Blue is good. Blue is good. Or green is good. Blue is partially, no, green is partially, blue is perfect, and red is no good. Good point. And the thing is that we just pick this set of variables. It is a sort of expert guess. So we think that these are important things when you write a paper, but we haven't tested them. And I read someone submitted a paper for NeurIPS where they actually tested some of these variables and found that some were statistical valid for these actually ensure reproducibility, others don't. So that's a good step, finding out which are the variables. We don't have the solution. And if we have this documented, so we could actually compute the probability of success. If I have this paper, it's documented these kind of things, I can do sort of a statistical analysis and say, okay, it's a 70% for me to be able to reproduce the result. Would I bother with it? Yes, maybe I would. It's so important. 30%? Maybe not. 5%? I'm not going to use my timer. So if we're able to do this, we can set the bar based on what we want to achieve. Thank you. There are some questions. Should we take them afterwards?
We can take one or two, but we're going to move to the next one as we set up.
I'll just my question is specific on the figures you shared earlier, where you're showing like only some percentage of people explicitly stated the research question or some such, and I wonder if that's making the results sound worse than they really are, because there might be some inferred research question that they don't state explicitly or things of that nature.
Yes.
And it would make me think that for this to have been, put into a major AI conference with a couple referees who are each thinking about, well, what is the importance of this paper? I would expect that if you look at more subtle cues that are not easy to pick out explicitly, you should expect to see maybe near to, say, 90% or 80% of people stating some form of research question, or maybe there are many papers where there's no need for pseudocode. So saying, downgrading them for not having pseudocode may be irrelevant.
I agree. So this study has problems. Totally agree. But I think we should be explicit.
Yeah.
So, and that's my point here. We should be explicit. This is what I try to achieve. This is the problem. This is what I try to achieve. This is what I achieved.
And I should say also, maybe there are limitations, but I think this is very good. I'm not saying that there's drastic problems. I think I really love this work.
Thanks.
Let's move to the next speaker, though. Sorry. We can have a discussion afterwards.
So, Just wanted to quickly introduce Dr. David Kennedy. Really excited to have him here today from the University of Massachusetts. Dr. Kennedy has really pioneered the neuroinformatics field and helped set the stage for reproducibility in neuroscience. Thank you.
And thank you, Yolanda and Netta, Paul, for the opportunities to work with all of you here. And I thank the prior talk because it sets up a lot of the things and very similar topics that will come up in the context of this. You even use the same way I introduce myself. By day, I do child psychiatry applications of neuroimaging research, trying to understand autism and other neurodevelopmental disorders. By night, I worry about the informatics infrastructure for trying to do that, the data sharing, the method sharing, and more recently, the reproducibility of the methods that we're applying to our clinical application areas. So most of what I'll be talking about today has to do with a center called ReproNim. It's a Center for Reproducible Neuroimaging Computation. It's a P41 that was awarded a few years ago. So we're sort of working on the issues related to that to try to improve the infrastructure that's available to the community to try to do in the neuroimaging subdomain a more reproducible, enhance the reproducibility of our research methods. In 30 minutes, I'm not going to be able to say a lot about many things, so I'm going to talk about this big field of icebergs. There's a lot of icebergs with lots of stuff under it. So this conversation, while there's 30 minutes of it, to discuss, later, it's, an infinite discussion, we hope to engage with you, the community, forever. So hopefully these slides will be available and there's little touch points to access and continue the dialogue. But the overarching theme I'm trying to go through today is, again, in just another domain, talk about the problem of reproducibility. And then, one of our core solutions that I'll try to work with, discussing with you guys, is the re-executability at the publication level. That this re-executability concept is really the key thing that we're sort of keying upon. And then we'll look at some of the solutions we're working on for supporting re-executability and some examples and some conclusions. As came up before, the exact how to convince people that there's a problem is very domain dependent. So the low-hanging fruit for us in the neuroimaging community is really to look at psychiatric applications, where a very stern comment from the director of the National Institutes of Mental Health came out a few years ago, which complained, quite frankly, that after 25 years and billions of dollars of research in genetics and in neuroimaging, the child you see with autism, at your child psychiatrist's office, or the adult you see with schizophrenia at the adult psychiatrist's office today, is very similar interventions and outcomes and prognosis compared to 30 years ago prior to all this investment. The scientists have done a great job of getting money. The scientists have done a great job of writing lots and lots and lots of paper, but in the end, it comes down to a profusion of statistically significant but minimally differentiating biological findings is a way to sort of characterize, many of these, what the literature is sort of full of. And that approximate replications of these findings are often, used, which neither confirm nor refutes any one of those individual observations. What we're doing a great job of is filling up our literature resources, PubMed, to find, oh, I saw this here, oh, I saw that there, and never really coming back to say, okay, how often is that seen, and what's the, how often do they constructively interfere or destructively interfere? We just put all these, positive observations in and build up all sorts of things, and never get that proper constructive, interference, to reduce the spurious ones. So there's lots of reasons why this sort of crisis, is, in this area. One of the biggest things is that many of our studies are, low power because they're small n, and even our large n studies, one can argue are kind of, small n. By the time we're looking at the bit of brain that really, says, if you do or don't have a socialization issue, or you do or don't hear voices, or you do or don't have certain negative symptoms, that's probably going to be a super small effect over things that are much larger effects. How old you are, what your gender is, what your IQ is, what your socioeconomic status is, what your age is, are all much, much, much larger biological effects than the ones we're actually trying to tease, the critical bits we're trying to tease out. So almost always, by definition, even in our large studies, we're really on the hairy edge of significant power. The answer to that is not, one could say, we're doomed, don't do anything, and that's one possibility. Well, the flip side that we're trying to promote more is not to not do small n underpowered studies, but to do your small n underpowered studies in ways that they can fit together and be put together into an emerging larger n more powered study. And again, I'm so happy to be in the home of Enigma here, who's really been pushing these types of concepts all along, so that we're happy to sort of follow along and try to be helpful in that type of domain. So there's issues with diagnosis, and there's issues with methods, and I already first showed sort of the publication bias is a problem, that we only tend to publish interesting positive findings and never the other many findings that often don't replicate. That's just not interesting, and so you don't publish it. This is a horrible slide. I apologize for the slide. It's really just to remind me to look at a particular example of the irreproducibility of some of the findings. This is looking at resting state, looking at the intrinsic connectivity of different bits of the brain in 20 papers in autism, and looking at findings of resting state differences between kids with autism and typical population. There's a bunch of anatomy across the top and a bunch of anatomy across the bottom, and the numbers that appear there are a publication reference to someone who saw a change in connectivity either in the positive red direction or negative black direction between region A and region B. Many years of studies. The problem is that's a very sparse matrix, and many of these cells do not have more than one observation in them, so they've not either been replicated or confirmed or denied. And in the worst, some cases have red and black numbers there. So some people say that's increased, some people say that's decreased. So the sparsity of that matrix is a problem, and the fact that there's not piling up of evidence for any one of those, or decreasing, or really clear degradation of different findings because of their inconsistency. That's just an example that everyone's happy to go off and write their papers, but it's really hard to do a proper rectification of what you're seeing compared to what the literature has already shown. Much easier just to say, my findings novel, and here it is and exciting, and not really, and find maybe an example that is similar. But not really delve deeply into it, just because it's hard. It'll slow down sort of how you're thinking about it. So ultimately, one of the biggest issues, and again, a lot of these concepts came up already, is that in your attempt to replicate something that someone else did, everything matters. Exactly what operating system your software is working on matters. If you use Linux versus Mac, you can get, and just looking at structural brain volumes, you can get different results. The tool that you choose to use matters. If you're using tool 1, FreeSurfer, or using tool 2, Ants, you don't and using the same sort of anatomic template upon that, well, sometimes those two methods of looking at the volume or the thickness of a particular thing does not necessarily give you the same answer across different tools.
Do you have an intuition for why, like, the operating system might matter?
The operating system has a lot to do then with the compilers and settings internally to that. And
is it like the code, the errors that might be in the code that come out in once?
It's not so much errors, but just different handling of floating point contexts and things like that. And that may not be one of the biggest differences when we talk about all these things, but it's certainly one, and it's one that we actually do have some control over. Yeah.
I think actually floating point calculations is the main problem when you do this type of, especially in these large models where you do lots of matrix multiplication, deep learning, and this simulation I talked about, the weather simulation, lots and lots of floating point calculations. Very small errors, implement different ways, and then you have different operating systems doing different ways. And if your CPU also does it in a different way than the other CPU, then you have lots of problems.
I didn't show you the plot on this one. There is in one of our other papers. In a lot of cases, it's very small. When we turn into looking at the volumes of very small structures, they end up, affecting those, a good bit. Whereas, the volumes of large structures, it's not such a big deal. But often we're looking at, small structures, the amygdala, and looking at, 5% changes, between, patient groups and, control groups. And we can see 5% changes just due to running it on two different operating systems. So that that kind of thing is there. Again, I'm not saying all the problems are that, but it's just one of the many things that are just pervading everything that we do. When we report a finding, we very rarely say the hippocampus is smaller in people with disease. Well, that hides all sorts of things that it cares what operating system, it cares what statistic I did, it cares exactly your characteristics of what patients with that, diseases and the tool that you use. We just turn that into that sort of high-level, summary. How much data you have or the specific, subjects that you have, matters. And that should be fairly intuitively obvious, but just a simple example, back in the early 2000s, there was a NIH pediatric normative sample, 500-ish, 400-ish subjects across 8 different sites. And so I just looked at that data for the gender difference in the hippocampal volume. And it's not really significant, crosses 0 pretty significantly. But pretty big error bars. It's a multi-site thing. It was done in the early 2000s, so the technology, the imaging was old. Then in 2011 or so, the PING, the Pediatric Imaging Neurocognition and Genetics study comes along and adds 1,200 more subjects to this, much more modern acquisitions, again 7 or 8 sites. And now you have a much larger sample. You begin to look at such an observation of the gender difference in the hippocampus, and now those error bars have tightened nicely based on our larger sample size. And this still falls within the range of the original findings, but now that you have better technology and more stable observations, that gender effect begins to emerge. And then when you add some more data, the ABIDE, the Autism Brain Data Exchange, and the ADHD 200, and all these samples together, this observation has begun to stabilize a little bit now that the different technologies are playing into that. So the point is, depending on where you were in looking at some observation, was that true or was that not? Well, it depends on the nature of the data that goes into those types of questions. Similar to what we heard a moment ago, because there's lots of issues about how we define things. Anyone talking about reproducibility had better spend some time saying what they mean by reproducibility. And so I think this falls in some of the ranges of things that we'd already talked about. To some extent, I key this on the original finding. The original paper had some data, had some method, and generated some particular result. The first issue, the part of this spectrum, is what I call re-execution. So can someone, the author themselves or the author's friend or author's enemy, can they get that exact same data? Can they get that exact same method? And can they generate that exact same result? That is just pure re-execution, not doing anything magical here. We're just verifying a day, a week, a month, 10 miles, 1,000 miles, 100,000 miles away. Can that same observation be regenerated? The sad news, and anytime I pick on the neuroimaging community, I'm old enough and have done all these things badly already. So anytime I pick on anybody, I'm picking on myself, really. But I cannot go back to some paper from 2011 on the corpus callosum volumes of kids and ADHD and re-execute that result. I don't exactly know where the data is. I certainly don't have that operating system, and I don't have that version of the software anymore. Oh well. But that would be re-execution. We do not routinely do that. Pick any normal recent papers for the most part. You cannot really even get the authors to re-execute that themselves, even if you could convince them to want to. Going beyond that, we get into this domain of sort of what I call generalization. So we want to be, if you took that exact same data and used a slightly different or similar approach, well, we'd hope that our original finding, would generalize to a slightly different, analytic approach. So if I take the same data and a similar analysis, a good, true finding should generate a similar result. Similarly, we can swap that and take the exact same analysis method and use similar data. And if that finding is, good, that should be able to hold up, across those types of things. And so then the sort of grand version of generalizability, or sort of the replication of that original finding, is to take similar but different data, or expanded data, a similar method, and be able to generate a similar type of result. Now, the thing I left here that is very tricky is similar is a completely open concept here. And while you would think similar is not such a bad thing to define, often when we're writing, similarity is at the discretion of the author to decide if it's in their best interest to claim similarities or not. Sometimes, I want to write a novel paper. I want to say, it's sort of default mode, but it's not all the default mode. I want it to be different than so-and-so's paper, so I get it published. It's not similar at all to so-and-so's finding before that. Well, it's sort of similar, but it's sort of not. Or if you want to build off of that point and go off and do some new cool thing, you want to make the readers trust you. So oh, yes, the first part of the analysis is exactly similar to that other result, and so that I can then go on and talk about whatever it is I actually want to talk about. So there's an awful lot of room for author discretion about exactly what similar is, and so that's not a good or bad thing. It's just the way we tend to write things. So the key that we're pushing on is to have, really put control over this re-executability back into the hands of how we write the original publications. The conjecture is if we write publications that are re-executable, then it becomes a lovely scientific process to explore the generalization of that finding. So it's not to be right or wrong necessarily about that first finding, but to be able to have you yourself or the community be able to then explore, if I add data to that, what happens? If I use a similar method, what happens? If I change some of the parameters in the workflow, what happens? So that we can really not just ignore all that, because right now without all that being explicitly exposed, we ignore all that, but to really just embrace the fact that this is the way I did it, this is the decisions I've made, this is the finding I've made. Now, if it's anyone cares, you can at least explore the generalization of that and understand when things don't replicate. It's probably not a question of, well, it becomes a question of, okay, why don't they replicate? Often it's, yes, my subjects are different, but my subjects are different because they have a slightly higher IQ, or because they had somewhat more negative symptoms in the schizophrenia group, or my kids with autism had a little bit more social issues than the stereotypic motor issues. That becomes not just ignoring, but we can embrace then the differences and try to understand. And often there's methodologic, as we already indicated, methodological differences. What is it about the operating system? What is it about ants versus free surfer? What is it about these things that generate those differences in ways that we can explicitly explore and not just wish away or hand wave or repeat the study because you get different answers. So the idea of this sort of next generation publication, I think we've sort of coined the term ReproPub, is that the publication is all your lovely words as usual. We need words because we need people to hear and understand the concepts that we're talking about. But you also have to explicitly indicate what data went into this publication. Explicitly indicate the workflow that went into the publication. Explicitly document the execution environment that was used for that, and explicitly document the complete set of results from the results of the initial processing and the results of that statistical interpretation. Now, as we saw before, that marking up that data is step one. It may not be able to hand it to everyone. And I'm not necessarily saying all data must be completely public for every publication we do, but someone had better be able to get to that data. Someone had better be able to be authorized under the appropriate data use and ethics agreements to be able to do that. And we should be able to do these things in a way that, again, anyone reading that can trust that can happen, and therefore be able to verify that the same types of results would occur. So by specifying each of these elements, what do we mean by specifying the data? Well, we certainly need a complete provenance of the data that went into a particular publication. Workflow, we need the provenance of that workflow that's being generated. Execution environment, we need the provenance, the description of where and how that execution and environment and workflow environments were generated. And also a place to retain sort of those complete results so that you can answer the question, did I find exactly what they did when they ran that? So these complete descriptions is really a complete provenance record for each of these different elements. I know there's sort of limited time. I just wanted to quickly demonstrate one of my own surveys, very badly done and ad hoc little survey that just asked the question, if we go backwards to the last 50 articles in autism imaging research, what's the possibility that we think we might be able to re-execute any of those particular publications? And just some quick survey of those different categories. About 50% of the recent autism literature does have some connection to data availability. Well, that's great. But the 50% that does have access to it is because it's already in one of these big data repositories, Abide particularly, or the, Abide principally. The other 50%, the new studies, the studies that aren't reusing existing data, aren't making their data available. So that's good and bad. It's great that some is available, but it's bad that most of it is new data that isn't becoming available. papers are very good at naming their software, so that's great. Papers are horrible about saying what operating system they're using. Almost zero of the papers we looked at actually said, I'm running this in Ubuntu 12.04, et cetera. And sort of a summary question is, to what extent do we think, and this is a fuzzy question, so take it with a grain of salt, to what extent do we think a reasonably skilled image analyst could re-execute that analysis? And given the context of papers, it's kind of on the order of 50% or so think that someone could redo that. Could the statistics be re-executed? That's a little bit better there. And the complete results are very rare. Only a quarter of the time may be available, at least partially, someplace. And to some extent, that's sad because we do have great data sharing, image sharing, resources. We have great results sharing, resources. So the problem is not so much that the resources for these, don't exist. The problem is, people are, just choosing, not to do that. And again, choosing because it's too hard, or choosing because they don't want to, and various things. And so again, a lot of the work that we do is trying to at least remove that it's too hard. The I don't want to is still a different problem. So trying to collect, so that was sort of setting up the problem with a lot of time, but to give sort of a high-level view of some of the solutions that we're working on, we've kind of broken that up into these 5, sort of major steps towards more reproducible neuroimaging research. And again, the point is not to read all of these, from where you are. There's a link, to these. But part of it is, you have to start thinking about reproducibility from the initial design of your experiment. When you design your study, you should think about getting open brain, getting your consent set properly for your data acquisitions. When you're planning your study, you should think about the semantic markup of the different elements that you're going to acquire. When you plan your study, you should do the pre-registration of your major hypotheses with some of the registration hypothesis registration services. As you're collecting your data, sort of phase 2 is make sure that we get our data into standard representations early on. BIDS is a wonderful data representation mechanism that's available to the neuroimaging community. That and DataLad has a lovely version control, so even data should be considered as close similarly to software in terms of needing version control and monitoring, especially as that plays into the ongoing data analyses. Data processing. To the extent we can containerize, we have the ability to control a little bit better some of the willy-nilly Wild West of the operating systems that we wander around with. So using containers gives us a way to lock down and document a operating environment. Also gives you something you can hand to someone else to reuse. So using containers, using resource managers so that you can write out those container specifications, and using annotation of the results. While each individual tool you use may annotate its results enough for its own local use, FreeSurfer, you don't have to worry about annotation. It gives you an aseg.stats file, and you know what that is. Well, the second you go and hand that to someone who's used ANTS or FreeSurfer, some other version, that file no longer becomes completely self-describing. So to the extent that we can build provenance into the outputs of all of our methods, then the sharing of those and the collecting of those becomes easier. Statistics are hard. There's a quote that I can't remember, so I won't try to remember that, but it's something about lies, damn lies, and statistics. Everything we do is underpowered, as I suggested, and there's a lot of things we try to fool ourselves around, this sort of magical 0.05, which is the barrier between us and publication. And there's a lot of things that we do that seem ethical at the time, but in retrospect, probably not the most ethical thing. I guess one side or the other of that 0.05 limitation. So again, there's a lot of things to keep in consideration. And then on the publication side, we should be using as much of our tools as possible to document and provide unique identifiers to the data, to the workflows, and to the complete results that should be available, and they should all be fair in terms of being findable, accessible, interoperable, and reusable. So given sort of those guiding thoughts, we'll take a quick look at some of the solutions that we're working on. Again, I have to be super quick here just to remind you of some things you might want to look into. There's a lot of different steps to the process. Let's not worry about those. But and one of the mandates is to try to take control of your data from the acquisition, get it into your lovely bids representations, get it into version control. There's tools called ReproNim, one of the tools that we're working with that from the get-go, from your scanner, and when you ingest that into your system, it's wrapped nicely. It's provenance aware. The provenance is represented for it, and it's under data lad and version control. Go check out ReproNim. We talked about containers. Well, container, not everything we have, has lovely containers available with it. We need to sometimes build containers around the tools that we want to run. So NeuroDocker, although we're going to now call it ReproNim because ReproNim needs to put repro in front of everything, is a relatively easy way to generate Docker files, singularity files for particular happy special software, and that can be easily used to create environments that are in containers that are then easier for sharing and documenting. So go look at NeuroDocker or ReproNim. Data lad, I referred to already, but what is data lad? Data lad is a convenient way to do versioning of data and tracking of data provenance. And there's some Yoda, things that I won't even remember what the story of Yoda is. But the point is, data lad is a way to version your data, but data lad can also version your containers. Data lad can also then mediate, the running of your containers on your data, all in a Git and Git annex, provenance aware and versioning aware, environment. So look at data lad and the ability to run, rerun, and containers run, different representations, all under sort of Git type, control. Running things locally is cool, but often we're doing large studies that can't necessarily all be done locally. So the tool is called ReproMan, is a reproducible image analysis management that lets you assign data, assign containers, assign environments to execute those on, which can be local or it can be remote. It can be your cluster, it can be AWS, it can be various places. So again, ReproMan is an attempt to help you manage execution from what looks like your own computer, but distributing that across the different environments where you can run that, all under provenance control and version control as well. Dave Keeter and Theo Van Erp are here, who've all been doing a lot of work in the NIDM, the neuroimaging data model, which is extensions of PROV that are trying to give us the underlying provenance models that can be a model that represents the data, the workflow, the results, types of things, so that there is a NIDM representation for each of the different things that we're working with. Now, in general, your end user never wants to see any of this, but all of this is part of the provenance that lets us go from a finding to a conclusion, to the statistics that was run, to the software that was run, to the analysis processing, to the subject, to the subject's behavioral characteristics. So all this is part of a graph of information that we really do need to be able to traverse so that we can easily find a result and know what the software, what the versions, what the other things are. So there's underlying NIDM representations for the experiment itself. For the and by the time we get into real fancy experiments, it can be pretty hairy. Each result of a statistical map, each result of a free surfer run, all have a model that represents all of the details and information that went in to that. These can be tracked and should be tracked, and so look into the NIDM and its derivatives. And again, it gets complex. By the time we get to complex analysis, that shouldn't scare us. That just means we have to work on ways to make our software be able to export that kind of information easily. The nice thing about marked up representation is we can then begin to create local data stores so that you can do these graphs. Once you have everything in a lovely graph, you can store that graph locally. Don't have to share anything, but you can keep that locally and have much better tools to navigate across your own data and all the studies that you've done and be able to compare today's study to last year's study in terms of similar findings and track the provenance and understand the differences and consider then rerunning or dealing with that. Managing things locally well also it just lowers the barrier to then sharing things and managing them remotely and globally much better, because then you can have data lakes and large scale stores of metadata at a larger scale that reflects and publishes and queries across to your local resources as well. So a bunch of tools that we're working on and more that I didn't even talk to that are all trying to help lower the barrier and give elements to being able to do these different types of things. So the last sort of mile of this is, okay, can we actually put all these things together into a particular paper? I referenced a simple one paper earlier on, which didn't do anything very interesting. It just, said you can document data, document the workflow, document the container, and, anyone could re-execute that paper that, we published, a couple years ago. Simple 2, the next generation of that is really trying to do something a little bit more interesting biologically and technologically. So we scoured the literature for some of the IQ-related questions in typical development and said, can we regenerate some of these high-level IQ observations by documenting the discovery, documenting the data sources, documenting the workflow, documenting the results, et cetera, et cetera. So there's hypotheses from the literature. There is a process that we had to go through to document and generate a unique identifier for each of these different elements of the publication. There are some details we don't need to worry about. But then the set of 9 hypotheses that came from those 3 publications that we sort of started from, we can begin to systematically assess that from the local publicly shared data sources that we have, can we recreate the data, the results that are coming out of those particular sort of high-level summary review articles. And in this case, they suggested that IQ and total brain volume correlates. Well, yes, we see that correlation too. It's not a very dramatic correlation, but it's certainly significant. So then across, the 9 different hypotheses that we scoured out of that literature, 1, 2, 3 of them didn't replicate, and 6 of them did across our initial analysis. And again, that's sometimes a non-replication in that they said it didn't correlate, and we did, said it did correlate, or they said it did correlate, and we said it didn't in that particular analysis. But again, that just gives us fodder to be able to explore more closely. So I'll just end with reminding ourselves that there's individual little things that each of us can do, and we don't have to necessarily get completely to full reproducibility, but each next paper that we write, if we just do one of these little things, a little bit better each time, and the community keeps doing one of these little things better each publication, then we'll sort of wander our way towards a more reproducible ecosystem of neuroimaging research. And lots of people participate in ReproNim. Jeff, some of our UCSD people, but Dave Keeter is here, and other people are probably on the telephone as well. And thank you for letting me tell you about these efforts.
So, Erik, would you join us? Thank you very much to both. And I wanted to open the discussion, but I wanted to make sure that it has a tone of what David ended with, which is that there's all these challenges to reproducibility, but the bar is so low. We can do so much to improve things, right? And when you put a whole list of things that I have to do before I try to publish my paper, and I'm trying to get the paper to a deadline of submission, it's kind of challenging and overwhelming to think about all these things, right? So, but I would like to open a discussion on what can we do to improve things, and what are practical things that have helped you all, or that you have seen are really significantly helpful to authors, that really change how people do things. So, okay.
So I'm wondering if there should be more of an extrinsic motivation, like people individually want to publish their papers, and so they might have a greater motivation to get their results out, especially results that look statistically significant, rather than make sure the results are reproducible or risk those results being found to be not reproducible. Something that, like, say, when I was submitting to Nature Human Behavior, they were asking for a lot of details about how I got the data, ways in which, motivating how to make the results as reproducible as possible. It would seem to me as if the main focal point would be making sure journals emphasize reproducibility, or conferences emphasize that these things have to be done if you're going to get this paper in. Otherwise, just saying, we should do this. Why would I take that extra effort?
Could I comment on that? So in the, I'm in cybersecurity, and one of our leading conferences in cybersecurity, the ACSAC conference, started 2 years ago, badges. And so after your paper has been accepted, if you provide the reproducibility, the data, and your experiments and your descriptions and everything, then you have an opportunity to get a badge attached to your paper. So
why does a badge?
Well, in the community, it starts to have, it's these small steps that you take that then you have more people, and then you have students, and then you encourage your students to do it. And So it's a badge. It doesn't change your acceptance rate,
But
but
it's-
it
but
has
some
the
of
It
the
was
ability.
a badge that the PC considered,
So-
borderline cases.
So let me say, ACM has had a group on reproducibility for some time, and they're promoting these badges as a way to advertise that the paper has a different quality. But I want to hear your reaction to this.
Oh yeah, I think this fair point is fair. So when we talk about it, we all know that we should do better and we can do better. But if it's easier for us to not do it, and then we don't. And the thing is that when we are judged for different academic positions, it's like how many papers do you have? So publishing more is better than publishing less. And I think conferences, they should start putting some requirements there. But I think funding agencies is sort of a key here. They could say, you should do this. You get funding, but only if you open up your methods and data and publish open journals, share data, share everything. But we all know that privacy issues cannot share all the data. And if you're a company, you don't want to share your methods and implementations and so on. So there are, and you cannot do it because you will not be competitive anymore. So there are problems. But I think if we say that we're a company, we cannot share data because it's our users' data. We cannot share the implementation because that's competitive advantage. We still want to share our methods with you. So our research is not very reproducible, but it's to some degree. But then others can do. And then we could say that, okay, this conference, we accept 50% papers that are fully reproducible with all data and code. And like 30% that is only data and paper, and then only 20%. So then you have incentives.
Yes, I want to agree that the journals need to be encouraging this way, although it penalizes the journal, to add these extra bars. So again, it's kind of has to be, a lot of doing that. The other place that's been half good and half bad, a lot of the funding in the United States comes from the National Institutes of Health. The National Institutes of Health requires now some rigor in reproducibility statements. They require data sharing more or less, to be discussed. So you often will see authors write about that in their proposals. Now there's no checking on any of that. So very often it's just the writing in the proposal and no check on that. I think it's going to be hard, but the thing that worked, the roadmap that we have that works, again, in the United States with the PubMed Central, at first, they said, every paper you write needs to be available, to everyone. The populace is funding this, those results, the paper needs to be accessible. So you should put, all your papers in, PubMed Central, a place where it could be, the content of the papers could be seen. Well, for a while, it was you should do that, and you're required to do that. Eventually, you do not get year two's funding unless you've done that for the papers you're claiming as your success, or you don't get your renewal, the next year if you haven't done that for the papers you need to claim as your success. So eventually, after a lot of time, they began to put the teeth in it and actually connected the money to the requirement. Right now, we're sort of in that, earlier, and it took a long time just to get the stupid paper, out there to the public, and a lot of, fighting and hemming and hawing, and the publishers didn't like it, and, the authors didn't like it, but it was the right thing to do, and eventually, after 10 years, they got there. The data sharing aspect of this is infinitely harder, but it's the same sort of roadmap. The theoretical requirements there. Eventually, if you're going to claim you acquired these 50 or 100 or 1,000 subjects, that better be in, someplace. If you're going to write this paper, that use this method, well, eventually, if you're going to claim that paper, you better have the the elements of reproducibility of that paper being checked off before that counts as a paper, before they give you year two or the continuation. It's going to be a long and hard path.
I think there's more and more pressure from everybody, but I will tell you very quickly, the most cited mathematician in the world, is a professor at Stanford, David Donoho, and he says the reason why I'm the most cited mathematician is because my papers have always been fully reproducible. And so people like to compare their work to mine because they can do that more easily.
And can I just add to that?
Yes.
Like some of my most cited papers, also the ones where I release the data and release the code, because then people can more easily compare it to their own methods. So that definitely increases citations.
Yeah, go ahead.
One comment on that. The thing is that I never use that as an argument because it's true, but only for a transition period. So right now you will be more cited, but when everyone does it, it doesn't change anything.
That would be a good problem to have.
Yeah, I agree. But
First mover advantage.
absolutely.
Other questions? Other comments?
I had actually another comment that I wanted to. So after this keynote by you in 2012, David Aha at NRL and I, we wrote a reproducibility process for this case-based reasoning conference. And we wrote it as a workshop paper and we published and we presented it to the conference. And we said, hey, let's do this stamps or marks that you've shared your data, you're reproducible to some degree. And the conference said, no, we don't want to do this. And the reason is, so if we set higher bars for our small conference, then people will submit elsewhere and we'll get even less publications here. Mm-hmm. So that's a problem for us. So now I'm at least trying to push IIII and ICHGAI to have some recommendations that are voluntarily to begin with, but then might change to be stuff that you need to do later. Because IIII this year got 10,000 submissions. If you get 10,000 submissions, then you can start setting bars, and people will still publish. If you lose 30% of them, okay. If you lose 50%, that's still okay. And it's probably the papers you don't want to publish.
So I have a question. So for each of the different domains, there's a slightly maybe different definition of when you declare my results I have reproduced a result from this paper. So, in AI models, there's one level of reproducibility because you may be reaching local minima and you may say, hey, I do better, or I've reproduced. In neuroimaging and biology, it's like, this part of the brain has been activated, but maybe one paper said the whole part of the brain and another paper said a smaller part. So my real question is, how do we go about defining what reproducibility means for each of our domains? That's my question to you two. Like, what's the process for that? Is it everybody in the community has to agree? No, that's not practical. Just your thoughts on that. Because you have two different domains here, right? Neurosciences and AI.
And we haven't even talked about social science, which is
right. So that seems to be a hard thing for me because I can declare I've reproduced your result, but maybe I haven't in your mind. So it's kind of hard to know. When do I declare victory?
I think my personal view, and that's something I'm trying to argue for, I'm working on all the time, is that I think we have the scientific process and reproducibility is an important part of that. So I think our definition should be the same for all domains. And I think also what is reproducible should be the same for all domains. And I think there is a solution. It's high level, because you're right, the details will be different. But at the high level, we should be able to really define this in a way that everyone should agree. And you see, we come from different domains, but when I looked at your presentation, I was like this, because everything you said reflected how I'm thinking, but we use different words. Yeah. And we haven't sort of agreed on the terminology. But I think to a very large degree, we agree about this.
Yeah. We've replicated. It's perfect. And the other thing, one of the issues, I guess, with exactly how you phrase that is I don't think replication is that specific. I think replication is an emergent property of the field that, while I can have one finding, if you find the same thing, that's good, but that doesn't, even if you find the same thing, doesn't mean that's right until, that, more commonly comes up, than not. So I think we need, I'm less worried about replication per se. I'm more worried about the ability to compare and see if the findings emerge, across the population. So it's not so much one person finding it. No, I don't think often people want to be the first person to publish something. Actually, I don't want to read the person who publishes it first. I want to read the person who publishes it second, who sees that same thing for the second time or the third or fourth time. So I think the point on reproducibility is how that emerges from all of us doing the right thing to do our studies, and then if that finding does or doesn't turn out to replicate or reproduce, that may not be for this month or this year or this 5 years to know how well that particular connection of brain is actually going to be. It's going to take a bunch of studies, the hundreds of studies that go into Enigma, finding that same thing. Then I become happier with that. So as long as you're doing, representing your results in a way that connects to the rest of the literature, then I don't care exactly if you found my result or not. It may live or not. We'll see in 5 years. I don't know if that was.
So the thing with I've got a question. What is the same? And when I talk about the same, so the results should be same. I think about these 3 levels. I showed you. So one is the only publication, other is if you have data, and the third is sort of if you have data, code, and the publication. And if you have access to your code and I have your data, I will be able, a much larger chance that I will be able to get exact same numbers as you got. Okay? If I have to do the implementation myself, well, I will not be able to get the exact same numbers as you did. And if I only have the paper and I have to get my own data as well as implement it, then of course I will not be able to get exact performance measures on as you did. It will not be the same at all. But still, we can say we reproduce results, but because results is a claim, and the claim is this sort of I claim that this is true when I do this, and if I rerun with my own own code on my own data and I still have the same claim, then I reproduce the results. So that is my thinking with these levels and the difference here. The problem is that for me, as the first author, as the original researcher, for me, I have incentives to not share. Because if I don't share, less work, and if you reproduce, the result is actually more general. So you've said, I've tested this claim you had on my own data and using my own implementation, and I get the same results as you. Which means that says that your method is more general than if I reran your code on your data and got the same result. But as a sort of independent researcher, that would be better for me because I don't have to implement and find similar data myself. So I actually trust your research more because you shared everything, and I have to do less work. So they're very different incentives for the original researchers and the independent researcher.
I want to mention, in my work, I don't say the same results, I say comparable results. And then it's up to the field or the authors or the type of research to decide what comparable means. Yeah.
One question, I think, for David. I really enjoyed both your presentations. I think you made such a strong case at the beginning of each of your talks for incentives to do this, and it's to fix the reproducibility crisis. And I think most of us realize in our fields that we're not getting reliable, trustworthy results. And I think now, through your work, people are moving towards that idea. So my question is this. I think, David, you mentioned the concept of a re-executable publication. And it seems to me that has huge impact potentially on collaborative science. So obviously if an individual paper could be re-executed, that's already good. It seems linked to another idea that I know, Yolanda, you and Netta have worked on, where you have a living or dynamic publication. In other words, not only could you do the things that someone has laid the roadmap for, but another group could join, or maybe a whole lot of data could be added. I just wondered if maybe David and maybe Yolanda and Netta, you have thoughts on this also. Are we close to the point where we can do an analysis again and make it easy through some of the tools, maybe that David you mentioned, or Yolanda that you're working on with Netta and your groups, to sort of bring the field together to do cooperative analyses using these types of principles?
I'm going to argue that we're close-ish.
You had a slide that had the results with 3 different.
Yes,
That is
so that
another thing.
was a
Was the
motivational.
same tool used for?
Yes, the same tool was used. That was prototyping. That was sort of the retrospective prototype of the idea that if you had done that analysis with a future free surfer, free surfer 6 back in 2005, you would have gotten one answer. But then as you added more data to that, that answer evolves. And the analogy I often try to use is the stock market. That initial paper is this IPO for a value of some p-value of something you observe, and then as other people add data to that, either your stock value goes up because your p-value goes up, or your stock value crashes because But if there's a crash, there's actually a reason for the crash, and finding out what that was, why people were unsure about monetary policy, we should figure that out. So yes, I think a lot of the tools we're developing are exactly trying, to do that, so that if I write my paper today and I can do a web, and our data discovery people can find, 100 more cases, tomorrow that could have been in that study, well, we should run that same analysis with 100 more cases. If and then when you go off to do your paper, you should be able to search the literature to see, has anyone done that, before, and am I stating a new IPO, or am I adding my data to my, buying someone else's, stock. So the ability to do that is certainly one of our goals. We're not quite there yet, which is why the ish was on the thing, but on the statement. But that's exactly some of our prototypes that we're trying to work towards.
Yeah, go ahead.
So I really like your work, and I think this is where we should go. As a scientist, we should stand on each other's shoulders when we do work, and as scientists, we really should want to sort of expand knowledge about the world. That is actually our job. But the problem is that our incentives are not drawn towards this. So for me to add data to your research, no value in me for doing that. So I have to publish my own research, and if I can get your data, perfect, but it has to be my research. So that's why I think we have to do something here, because that would be great. I totally agree. We would understand the world better, and that's what we want to do. But the research world, as it's set up right now, it's not drawing us in that direction. Maybe.
So I want to ask Neda if you have other comments or a question or a topic you wanted to raise.
Not really. You just mentioned what I was going to say, is that even if we're developing the tools, the motivation is a little behind that. So if we, are able to, work with the funding agencies and the journals, like has been mentioned, and okay, if you add 10,000 more samples to this, then sure you can get a Nature publication or something. That would be ideal, and people might slowly add their data in. But right now, putting a small data set in like a larger pool that's already been published, there's not really much motivation. Yeah, I think it's really.
Meanwhile, people have diseases and our planet is suffering, and here we are hoarding the data that would solve very important problems. So I want to make a comment, which is that neither one of you mentioned intermediate results. And what I have found is that they are incredibly powerful. So especially when you point out that free rider versus ants, we find this in proteomics, right? Different protein matching algorithms. So publishing intermediate results allows others to not have to reproduce the entire thing, but actually explore different engines and different analytics. So we're going to finish here. I want to thank you both very much. We want to thank you both, and this was very useful. Ask us questions, and I run a site called scientificpaperofthefuture.org that has a lot of good, simple things that you can do in a couple hours to improve your paper in a couple hours.
I do have to admit, even though I probably didn't cite it, probably a lot of your work has motivated a lot of the work that we're thinking about as well. So thank you for.
Likewise. Thank you.